We are going to review section 6.4. So you will need pages 46 through 48 in your homework packet. If you don't have access to these pages, you can always write these examples out on a separate sheet of paper. So I'm going to scroll down to problem number 4 and start there. So in number 4, it says to draw a picture, define a variable, write an equation, and solve. So you have an angle XYZ and angle ABC that are supplementary. If angle ABC is 54 degrees less than the measure of angle XYZ, find the measure of each angle. So first of all, supplementary angles add up to 180 degrees. Okay, so we need to remember that. So now we know the measure of angle ABC is 54 degrees less than the measure of angle XYZ. So we don't know the actual measure of angle XYZ. So I'm going to start there and define my variable. So I'm going to let x equal the measure of angle XYZ. Okay, we also don't know the measure of angle ABC. All we know is that it's 54 degrees less than whatever the measure of XYZ is. So we define the measure of angle XYZ as x. So now let's define the measure of angle ABC. If it's 54 degrees less than the measure of angle XYZ, which is x, that means that angle ABC would be x minus 54. So x minus 54 will be the measure of angle ABC. So if these two angles, XYZ and ABC, are supplementary, that means that their measures add up to 180 degrees. So the measure of angle XYZ plus the measure of angle ABC is going to equal 180. So the measure of angle XYZ, we defined that as x, plus the measure of angle ABC, that would be x minus 54. And that sum equals 180. So we need to solve for x. So add your like terms. X plus x would be 2x minus 54. I'm going to rewrite that as plus negative 54 equals 180. Now to solve for x, we add positive 54 to both sides. So we get 2x is equal to 180 plus 54. It's 234. Now we divide both sides by 2. So x equals 117. So that's just the value of x, but we're asked to figure out the measure of each of the angles. So since we defined x as the measure of xyz, and if x equals 117, that means the measure of angle XYZ is 117 degrees. And now we need to figure out the measure of angle ABC. So the measure of angle ABC is x minus 54. So if x is 117, you want to take 117 minus 54, and that would be 63. So the measure of angle ABC is 63 degrees. Now to check if that's correct, you can check if 117 plus 63 has to equal 180. And it does, so that means we solve correctly. You don't need to do a check, but it helps to verify if your answer is correct. Okay, so you're going to try number 5 on your own. Okay, I'm going to go to number 6. Find the missing angle measures of the figure below and then justify your answer. So you're told that the measure of angle KON is 62 degrees. So let's find all the other angle measurements. Angle MOL across from it, that would be vertical to KON. And you know that vertical angles are equal or the same measure. So that means MOL would be 62 degrees. So the measure of angle MOL is 62 degrees as well. Okay, now angle MOL and LON, okay, I'm highlighting LON, those two are going to be supplementary because they form a straight line, or another word for that would be a linear pair. So the measure of angle LON would be 180 minus 62. So 180 minus 62 is 118. So that means that the measure of LON is 118 degrees, and our justification would be that it's supplementary to angle MOL. And prior to that, I forgot to write down that MOL was 62 degrees, and that's because it's vertical to angle KON. Okay, now we need to figure out the measure of MOK. So if LON is 118 degrees, then MOK is vertical to LON. So that means that it would also be 118 degrees. So we can say our justification would be that it's vertical to angle LON. Okay. Okay, try number 7 on your own. Okay, number 8 is asking you what is the ratio of pi. So recall that the circumference is pi times the diameter. So if circumference is pi times diameter, and if we divide both sides by the diameter, we get the ratio of pi is c divided by d is equal to pi. And that's because the d's cancel out on the right. So pi will always be the circumference divided by the diameter. So if you take a circle and measure its circumference, and you divide that by the diameter of the circle, you will always get something close to pi. Okay, So you can skip example number 9. I want you to try example 10A. You can skip B. So just try example 10A. Okay, I also want you to try example 11A. So find the radius, the circumference in terms of pi, the approximate circumference, and the area. I'm going to go over 11B. So in 11B, you're told that the circumference in terms of pi is 36 pi feet. Okay, so remember that circumference is pi times diameter. When you leave pi in there, that means that this 36 here, just the 36, is the diameter. Okay, so if 36 is the diameter, then remember that the radius is half of the diameter. So that means the radius would be 18. I'm going to make sure I have my units feet. Okay, now the circumference, the approximate circumference, that means you use pi equals 3.14. So remember to write down your formula, C equals pi times d. Replace pi with 3.14, because that's how you find the approximate circumference. Then you multiply the circumference by the diameter, which is 36. And you should get 113.04 feet as your circumference. Okay, for the area, remember the formula for area is area equals pi r squared. And r squared means r times r. So you can write the formula as pi times r, so you don't confuse it with 2 pi r. So it means r times itself. So since we're finding the approximate area, you do replace pi with 3.14. And then we're going to multiply the radius, which is 18, times 18 again. So multiply that out. So when you multiply that out, you get 1017.36, and remember your units for area would be feet squared. Okay, so you can skip number 12. So please remember to do problems 5, 7, 10A, 11A, and then submit a picture of your work.